Today I'm going to be doing something a little bit different. I'm going to be forge welding, but instead of trying to do the best I can forge welding, I'm going to see if I can screw it up intentionally. This is an old story that's been around for a while, and I had totally forgotten about it until somebody recently suggested that I do it as a video. And the story is that there was a blacksmith that went into another blacksmith's shop and asked him to show him how to forge weld. And while his back was turned, he threw a couple of copper pennies into the fire. And those copper pennies fouled the fire so much that he was not able to forge weld. So, of course, he was very embarrassed, and the other smith had a good laugh at his expense. So I'm going to give that a try today and see how it works. So what I'm doing here is a few test runs to make sure that this isn't one of those days where I can't get anything to stick anyway, and it's a viable day to try this test. So I have a regular fire. I didn't clean it out any special way. I just started working, and I've managed to do a few forged welds. I have to admit, I don't do a lot of what's called drop tong welds, where you're taking two separate pieces and joining them together at the anvil. It takes a little bit of coordination and a little bit of timing, which some days just doesn't happen. But I wanted to use this technique for this experiment because when you're doing this type of weld, the pieces are separate in the fire. They're not held together or clamped together up against each other. So the whole weld area is exposed to the fire. So if there's any off-gassing or anything going on in there that could ruin the weld, it's going to happen more than likely with this type of weld rather than just a straight lap weld or something where most of the weld joint is protected from the fire. I apologize for not moving the camera here, but I'm basically just cutting off the weld and recycling the bars for the next forge weld, so there really isn't anything interesting to see. So at this point I've done half a dozen welds and I feel pretty good. I'm pretty confident that things are going along as planned. So now I'm ready to introduce copper into the fire. For the prep for the weld, I'm just doing a really basic scarf joint. I'm really just tapering the ends of the bar. I'm not really concerned about making sure that the ends are totally concealed and all that stuff. This experiment is just to see whether the bars are going to stick together or not. So here's the coil of copper that I'm throwing into the fire, and I'm estimating that it's about the equivalent of 2 pennies. The copper went in, I waited for it to melt, and then I started heating up the bars for the weld. And as you can see, even though it took me a little while to get around to it, I was able to get the bars to stick. So for this weld, I can't say that the copper was any detriment at all. This is the second heat from that first forge weld with the copper, and when I stuck them together, I know you're not going to be able to see this, but they were kind of half lapped off of each other, so I'm trying to hammer that all back into shape here. And even though it's a pretty ugly weld, everything is sticking together, so again, I can't say that the copper had an effect with this one. So for the first test, I just had the copper in the fire. For this test, I want to determine 100% whether or not copper affects the weld at all. So what I'm going to be doing is brazing the end of each rod with the copper and then attempting to forge weld that. So here I am trying to weld with the brazed ends, and I can tell that these are like glass rods. They are not sticking at all. And this is the second attempt with the same rods, and I'm getting the same results. I got one little area to stick a little bit, but basically it's not working. So what I'm doing now is cutting off the scarfed ends of the bar. It's not quite the whole area that I had brazed, but I would say that 80 to 90% of that copper is gone with these cuts. So this weld is to see whether or not that little bit of residual copper that's still on the bar is enough to affect the weld. So here's the third attempt trying to weld those two rods together. And I'm getting the same results. They just feel like two glass rods. Normally when you put a weld together, it actually starts to stick. It feels like you're pushing two pieces of clay together. They just sort of naturally want to fit together. These, it's fighting me the whole time. For this final test, and again I apologize for not moving the camera, I'm cutting the bars right back to clean metal that has not even gone into the fire. So there's absolutely no way that there's any residual copper on those pieces, and I'm going to see how they weld. So here are the two cleaned up bars, heated up in that cruddy fire, I might add. I haven't cleaned out any clinkers or tried to do anything to that fire, so it has the copper coil in there and the copper that dripped off of the bars when I was brazing the ends. It's all in that fire, and I got this weld to stick. I'm sure it isn't a great weld, but I got the bars to stick, so I know that it's clean and there isn't anything that has fouled the surface and prevented it from sticking. So for the first time tonight, I'm cleaning out the fire, and these are all the clinkers that were sitting underneath the coals while I was welding. And you can tell that they're very metallic, so there's no shortage of copper in there. So based on this crude experiment, I'd have to say that just having copper in the fire isn't going to affect the ability for the forge weld to stick. Now, I haven't done any strength tests on these welds, so I don't know whether the strength is compromised, but that wasn't the point of the story. The story was that the welds were not even able to stick, so that I don't think is true. But if there was ever a situation where the copper was able to get onto the metal, then even a little bit of copper definitely fouls up the surface enough to prevent a weld. I don't have any question about that. So if you can manage to keep your fire a little bit cleaner than this, you shouldn't have any trouble welding. Hi, I'm Dennis, and thanks for watching. As most of you know, for the past few years I've been producing YouTube videos on a part-time basis. I am now looking to turn that hobby into a full-time job, and for that I really need your help. A small monthly contribution from a really small number of viewers will generate the income that I need to achieve that goal. So if you're interested in the work that I'm doing and you want to lend your support, please click on the Patreon icon at the bottom of the screen. Thank you. We'll see you next time.